Welcome to Fabrity Talks podcast, where we explore software development, generative AI, industrial IoT, and data engineering. Our goal is to provide IT executives with practical business insights that can be seamlessly put into practice in their organizations. You can listen to every episode of our podcast on Spotify, Apple Podcast, Amazon Music, and YouTube. If you want to know more about what we do, visit our website at fabrity.com. Now, let's get started.
Hi, welcome to the Fabrity Talks podcast. I'm your host, Jarosław Ganczarenko. As an IT content manager at Fabrity, I focus on creating content that drives informed decisions and helps achieve strategic business goals. Today, I'm joined by Dr. Wojciech Jamrozik, an industry automation expert from the Silesian University of Technology. Together, we will be discussing the current state of AI applications in industry and trying to make some predictions for the new year 2025. Hi Wojciech, it's great to have you here.
Thank you. I'm really looking forward to our conversation today.
Great. So before we dive in, let's start with a warm-up question. Could you tell us a little bit more about your professional and academic background?
Yes, of course. I have been working at the Silesian University of Technology for over 15 years, and from the very beginning, I've been focused on machine diagnostics and machine learning methods, particularly in such applications. Moreover, for many years, I've been building automation systems and programming various controllers. I also collaborate with several companies involved in the integration of predictive maintenance systems. Moreover, I make an effort to share insights at the industry conferences about various technological innovations that may be interest and inspire representatives of the industry.
So that's great to hear because we hope that together we can discuss interesting things that will be interesting for people from the industry. And I believe we met on the conference and on maintenance conference, I believe, some time ago. Yes, in Wrocław.
Yes, for sure.
Let's start and discussing more in details our today's topic, which is the current state and outlook for 2025 of the AI in the industry. When we talk about AI in the industry, the first application that often comes to mind is predictive maintenance. You mentioned that you were dealing with the predictive maintenance. So my first question is, how can AI help streamline service activities and generate savings?
You are absolutely right. When it comes to the AI industry, the predictive maintenance is usually the first thing people are thinking of. But it was a really elaborated industry, the predictive maintenance, before the machine learning was a buzzword. Even in Poland, we were trying to incorporate some predictive maintenance method in the field of machinery diagnostic, but now when the AI is really a buzzword, we are trying to push it. At its core, the predictive maintenance is really about identifying as much accuracy as possible, the timing, location, and the scale of potential fault. But it is particularly challenging in complex systems where you have to monitor numerous variables that have even various modalities, and it has process settings, different measurement signals like vibration, ultrasonic signals, and other process data. Plus, you need to understand how these measures values related to the conditions of machineries and the process they support. So you have to know those relations between signal you are measuring and the conditions of the machinery. And
this seems that sorry to interrupt you, but this makes it ideal scenario for neural networks that are incredibly effective tools for modeling these relationships.
Yes, of course. For analytical systems, it was really hard to deal with because for complex systems, when you are trying to analyze it with, for example, some systems of equations, it is really complicated. For methods like neural networks that can generalize knowledge and analyze complex data, you can achieve more
accuracy.
Yeah, good work. Because they excel at generalizing some patterns, which means they can predict failure values of measured signals and assess the conditions of observed equipment. For example, you can process real-time data from machine sensors. Yeah, like I mentioned, temperature sensors, vibrational sensors, and so on, and quickly identify various types of anomalies that might indicate the potential technical issues. So say the neural network detects unusual vibration patterns, it could be a warning sign that your bearing is in bad conditions, or other things like, for example, unbalance occurred in your machinery systems. Of course, implementing such tool requires a solid foundation because neural networks rely on training data. So you have to have historical data collection. Also, you have to have robust measurement systems and the right computing infrastructure to support your inference system. The good news is that for common types of machinery, software vendors often provide pre-trained models. So, for example, when you have a pump or a fan that are common in industry all over the world, you can use a model that was pre-trained by the solution supplier, and then it can be incredibly useful for some companies that lack a rich historical database. Next thing is that those tools are highly modular, so they can be deployed for a single machine or scale up to cover entire production line. In the end, AI-powered predictive maintenance, it not only helps companies to prevent costly unplanned downtime, but also extends the lifespan of equipment and optimize resources allocation. It is always a win-win situation for both sides. From one side, you have the operational efficiency, and from the other side, you try to achieve cost savings.
Yeah, okay, that's good point. But you said that everything is all about data. So if you do not have historical data, you have a problem because this predictive maintenance scenarios work when you have a large amount of historical data. You mentioned the pre-trained model, so I'd like to know more what to do if you do not possess this historical data of your machines. How can predictive maintenance be implemented in such cases?
Yeah, it's a great question and good point. Yeah, like I said, the pre-trained model are a good solution for some usually used machine. But when you have a complex, unique machines that are operating under varying conditions, that are using different various materials, different input materials, are producing diverse outputs at varying efficiency levels, then it could be not the solution for you, those pre-trained models. In this situation, you need to use a completely different approach because, as I said, there is in most cases no historical data capturing enough use cases for machine conditions to rely on. So in such situations, a long-term strategy is essential. You don't have to make everything at the first stage of predictive maintenance implementation for your, for example, machine or plant. First, mainly we focus on building a model for fault detection. So we are trying to build a model that gives us so-called binary information that the machinery is okay or not. We are not trying to tell what is going with the machine in detail. So we are trying to identify any deviations from the machine's normal and optimal operation. Once that's in place, we can start developing more complex model for fault identification and localization. And these advanced models help pinpoint the type of fault when it's occurred, its severity, and how quickly it is progressing. So another option is to leverage ready-made solutions because there are also ready-made solutions that are more advanced, I think. For instance, there is one company that claims that its decision engine was trained for data from over 450 million machine operating hours. Such pre-trained systems can serve as excellent starting point. It is like you are using some standards. There are also some threshold values that you can use when you don't know or your knowledge about your machinery is not so high. It is the same situation for building AI models. You can use these pre-trained models and it is great start points. And then you have to fine tune these models as the diagnostic systems gather more and more operational data over the time.
So what about digital twins?
Yeah, digital twins and any other simulation models are really good solution in several situations because these virtual replicas of machine and processes allow us to simulate a wide range of non-standard scenarios. For example, you don't want to simulate on a real equipment some faults because you can destroy your machine. And it is really safe for your simulation models. So you can gather some data for scenarios that will probably never occur on your real systems, but you have to be prepared for it. So beyond the simulation, digital twins also can generate synthetic data, which can be valuable for training those intelligent systems. This makes them powerful for implementing, of course, predictive maintenance and also other methods that use AI that can be even beyond the predictive approach in the case when you are lack in real world historical data.
So I think digital twins are a topic we discussed extensively on our podcast. For example, in the episode 6, where we have a guest, Piotr Wiśniewski from DBR77, and a company that provides such a digital twin solution.
Yes, exactly. Because when we face some challenges in obtaining data, a digital twin solution can help. There are several vendors that supply some solutions using those digital twins. For example, the ABB Ability Genix suite use digital twins to simulate and predict equipment behavior, and this allows us to optimize the operations and better plan maintenance. In my opinion, the use of machine learning and AI methods can go far beyond predictive maintenance because by analyzing equipment behavior, it will be possible to precisely identify the root cause of failure. So even if there is some significant time offset between the initiation of the damage process and the actual fault, this so-called root cause analysis will reach a new level, enabling both the prevention of failure and the development of new guidelines for equipment manufacturers to improve reliability and maybe extend the effective operational time, which is closely connected to the financial success of the whole company. Because when we don't produce, we cannot earn money.
Okay, so let's move from predictive maintenance to another area in the factory where AI can make a real impact, and this is one of my favorite topics, mainly edge computing. This idea of AI on the edge is essential for scenarios when we need to quickly analyze large amounts of data, like processing images from industrial cameras, all while keeping latency low. It seems like this technology is becoming more and more common. What's your take on this?
Yeah, absolutely. The edge computing is playing an increasingly important role in modernizing production processes and improving its maintenance. But it's all about processing the data right when it's generated. We want to shorten the path from the measurement to the decision. So the really nice solution is to have it on the device itself or nearby, rather than sending it off to a central server or to the cloud. In industrial settings where even milliseconds matter, being able to process data on the edge is a real game changer. But the speed advantage is just one of the part of this equation, because by reducing the amount of data sent over the network, edge computing also lightens to load on communication infrastructure and lowers the data transmission cost. It is really important when we have complex production line, when we gather, I don't know, maybe thousands of signals that I really should be processed in real time, and then transferring some diagnostic information through the communication systems can be really demanding. So when we can shorten the path, it can be really a boost for our infrastructure. Next, we are increasing the security because the data stays within the local factory network, and we are minimizing the risk of leaks or unauthorized access. And all of these benefits are why edge computing is becoming such a critical path for industrial operation, especially now when the OT infrastructure is even more prone to cyber attacks. And then when we combine the edge computing with AI, we unlock even more potential because AI on the edge enables systems to analyze data and make decisions in real time. And we can do it without having to rely on central servers. So when we have a factory that it is well distributed in space, we want to do it in place, especially on the machine. So it allows us to have the immediate response to changing conditions, Thus, we improve the system autonomy by reducing the dependency on stable network conditions and optimize the resource usage by easing the burden on central servers and networks together.
Okay, just the use case that comes to my mind is the industrial cameras that are observing if people wear helmets. So it's like we can use AI-powered industrial cameras to analyze and to signal out all the problems with the safety, for example. So this is the first use case of the edge AI that comes to mind because images from cameras are very heavy load and cannot be sent to the central server because they need to be analyzed on the edge. Exactly. Yes.
Yeah, it is a good example for me. The example that comes into my mind is, for example, the gas mine factories in Poland. We have really small gas mine factories that are distributed in some area and are really far from each other. And the transmission of data, for example, to our central SCADA systems is made through sometimes low speed cellular network. So when we don't have to transfer a diagnostic data, a large amount of data that is crucial for this type of machine operation, but we can only transfer some binary information about the condition of this machinery, it can be really crucial to operate those equipments at high level.
So edge computing is the use case for the situations where there is low connectivity, low network connectivity. So you cannot send much data. So in this case, you mentioned,
Yes, of course. It's one of the tasks. There are many other situations when you can use this edge computing, and the industry that supply the systems for the industry are making it much easier because now the PLCs are evolving, are incorporating many industrial capabilities. It is not only on programming because now they have some additional modules that they can accelerate algorithm, include predictive models, so are designed to support AI at the edge. So this makes implementing local diagnostics and predictive systems more practical than ever.
If I understand correctly, is that the hardware is specially equipped with the solutions that allow to use edge AI. Yes, so that to streamline the algorithm and the predictive maintenance models.
When you want to use AI on the edge, you have to have specially designed hardware because without it, even those so-called small models are really demand when we are talking about some computational capabilities. So without specialized hardware, it is not possible to use them. But at the market, we have some solutions to assure the demanded capabilities to use them.
So let's move from this AI to another hot topic lately, mainly generative AI. I need to ask this question because there has been a lot of buzz about how large language models can be used in different business scenarios, including factory maintenance. And this is also the topic we discussed extensively on our podcast. And even we've built something along these lines, like a virtual assistant for production department that uses natural language processing to analyze data from industrial IoT sensors. And the maintenance engineer or technicians can communicate with this assistant using natural language prompts. So, but the question that appears here, which I believe is very important, is that LLMs are normally general purpose models. So how these general purpose models can be applied effectively in an industrial settings when the specialized knowledge is required?
Yeah, that's a really great question because the general knowledge of the large language models bring both an advantage and challenge when it comes to solving specific industrial problems. It can be maintenance problems, troubleshooting of machinery, or even programming of various controls. Because from the one hand, the broad understanding of context is a huge plus. They can pull insights from other industries, suggest solutions that may not have been considered otherwise. Yeah. But for example, a predictive maintenance approach that can be used in aviation, we can transfer it to, for example, oil and gas sector. And an LLM may identify this type of connection. This versatility makes them especially useful for companies that work with a mix of different machine systems, technologies, without needing to train a separate models for each scenario. with what also can be the case. And LLMs are also great for bridging communication gaps. Yeah, they can be used to take some complicated technical jargon and translate it into a plain language, or even create clear documentation. So, in an industrial environment, when engineers and not non-technical staff often have to work together, that kind of capability is really a game changer. Plus, the ability to combine knowledge from different areas can spark maybe some innovative ideas, because while borrowing maintenance strategies from healthcare equipment and adapting them to maybe manufacturing. So another big advantage is speed. Yeah, so LLMs can sift through huge amount of data, manual, I don't know, sensor logs, maintenance records, and quickly pinpoint issues or recommend optimization. So that means problems get solved faster and operations stay on track. So while LLMs are in most cases a general purpose models, the flexibility and ability to adapt make them valuable tool to many industrial settings.
Yeah, okay. Just when you're mentioning advantages of large language models, I need to add the ability to communicate in different languages. So you might ask questions in your language, native language, and the model automatically translates the documentation that can be in English to your mother tongue. So that's a great advantage, especially when you are working in the different countries.
Yeah, yeah.
But of course, I agree with you that there are clear advantages. But what about our industrial setting? I think here specialized knowledge is a key to everything, key to success.
Yeah, the key to success is knowledge that now it's in possession of some domain experts. And one of challenges that is with LLMs that they often don't have this deep industry specific expertise. So sure, okay, the general knowledge is broad, but that doesn't always translate into solving some highly specialized problem. For example, diagnosing a unique fault in a custom designed machine may be far beyond their capabilities, because this model was trained, for example, on some standard when some general guidelines about how this type of machinery is diagnosed is present. Yeah. So sometimes they can generate also response that maybe they sound confident, but are actually incorrect or inappropriate for something that can be risky in critical industrial situations. So these mistakes can lead to a costly or even dangerous consequence.
Yeah, the LLMs are great, but they tend to hallucinate. So that tends to give answers that are not correct. So which is a little bit dangerous in an industrial setting. Yes.
Yeah, one of things that most of companies are currently working at, those companies that are providing LLM models, is to mitigate those hallucinations. So yeah, it's very, very important, especially for the critical use cases like in industry. Yeah, it's different when you want to generate, I don't know, maybe some picture for birthday or your kids, and it is different when you want to use this model to control some machine in a factory. Yeah, so the mitigation of hallucination is very, very important.
Okay, so what about the knowledge cutoff date? Because general LLMs are trained on data that are available until a certain point in time. So there is a knowledge cutoff date for every model, like ChatGPT, for example. It is 2024, for example. What about the real-time data or the latest maintenance practices or cutting-edge industry standards? How to include them in the training?
Yeah, in most cases, we are trying to fine tune those models with a data specific that to give an industry that is more accurate in time and is more accurate for the specific solutions. It can be some instructions, some machine logs, some operation manual, so actual technical reports. So this makes those models much better at tackling some specialized challenges. However, they should always be seen as a tool that supports expert. We are not at the point that it is a standalone solution. So they broad insights can be complemented by the deep and some focused expertise of engineers and technicians. Now we are trying to pair LLMs with specialized AIs, but when we use, for example, model that can analyze some vibrational signals in predictive maintenance. Of course, you incorporate the knowledge from the LLM, the knowledge from the specialized models, but it is really critical now to have there an expert that checks the response from the models. Those answers must be reviewed by experts, especially in those scenarios when those errors could lead to serious consequences.
So in industrial settings, there is no such thing as replacing engineers by AI. So it will be so that engineers will be working alongside with AI or will be using AI to streamline their work. So, but still on the top of this, it should be an expert that, works with the AI and other technologies
Now
to
AI,
deliver results.
yes, of course, now AI models can be regarded as, I don't know, maybe partner or supporting partner from the team of engineers, not a standalone responsible, maybe we can call it person that is only responsible for making strategic decisions.
Yeah, so we can regard AI as a junior engineer that, needs supervision. I like this comparison. Okay, let's talk about other technologies tied to industry 4.0. One of the key elements in building the factories of the future, so also called smart factories, is the human-machine interface, or HMI for short. Generative AI systems seems like the perfect technology to make this communication between the human and the machine even simpler and more natural. Do you know of any real-world examples where Gen AI is being used in HMI interface? Are companies, to the best of your knowledge, experimenting with this idea?
Starting from the beginning, this is a good question because the generative AI has a huge potential to change how people interact with machines, especially in industrial systems, but not only. It's being used in both highly customized systems and more widely accessible applications, all with the same goal: simplifying how the work with machines and how we interact with machines. So the one of the biggest advantages of Gen AI is that it allows communication in natural language. So it makes the interacting with machines more intuitive, even for the junior personnel or some untrained operators. So workers don't need to navigate through complicated interfaces or even know programming languages, because they can just say what they need and ask questions in the natural language. So for example, you can use a chatbots to interact with the ERP systems, and bots can understand natural language and answer questions about, for example, some operational data. As it was already mentioned, another game changer that AI can handle is use of multiple languages. So, for example, in factories with international teams, it means that worker can interact with systems in their own language, which is beneficial in two ways. For example, we can reduce mistake caused by the language barriers, both when entering queries and when understanding the answers. And you was asking about some examples. So yes, of course, industry is experimenting with this approach, and suppliers of various types of systems are trying to introduce some new capabilities to them. And now they cannot omit the generative AI. So, for example, we can take Siemens as example. So they partnered with Microsoft to create the Siemens Industrial Copilot, and it uses generative AI to speed up automation processes, for example, in SCADA systems. So the Copilot helps engineers to write, optimize, and also debug some complex automation code much faster than it was without it. Thanks to this AI, the systems can analyze data, generate code that's more efficient and less error prone. So it also has some real-time simulation capabilities. So the engineers can test their solutions before deploying them, which saves ton of time when making updates or modernizing systems or adding some new capabilities to them.
Okay, that's interesting.
Yeah. For example, other company is Aviva that has the product that is called Industrial AI Assistant, and it integrates Gen AI with industrial data and SCADA systems, letting user ask questions in natural languages. So it's a super easy to use systems. Just speak your question and it will analyze the data, generate reports, maybe suggest some ways to improve your production process. So yes, as you see, the industry is not only experimenting with Gen AI, but already applying it in some situations, making the interaction more smooth, more intuitive, and incredibly efficient to modern industrial environments.
And yes, I think this is also important because human-machine interfaces are also regarded as a backbone of the industry for all. So it's the basic technology that enables the automation and streamlining the work in the industry for all. Yes. Okay, let's move to another technology, which is also a hot topic. I mean, autonomous AI agents that can perform tasks on their own without human involvement. And some solutions even use multiple specialized agents that each of them is focused on a specific task. And there are some, like Gartner, that predict that this year, 2025, the autonomous AI agents will be one of the hottest Gen AI trends. I'm also interested to know your thoughts about this topic.
Yeah, it's a really interesting topic because the development of AI agents is really fast last year, and over the past couple of years, we've seen the huge advancement in AI. Yeah, we were talking about language models. We highlighted its strengths and weaknesses in different approaches, but still we were talking about one model. Yes, so we were talking about some single agent system that it is great for a specific and well-defined task. We use this one model to handle a particular job, mainly in some stable conditions, for example, like generating text or creating images. Yeah, they are straightforward to set up and manage, but they don't really manage well more dynamic or some unpredictable situation. And now we have another paradigm that it is growing really fast, and we can talk about some multi-agent systems that involves multiple models that are working together to tackle more complex problems. So they are designed for dynamic environments where flexibility is key. So think, for example, of coordinating robots on a production line or managing traffic in a busy city. These systems require a lot more planning, a lot more communication between agents, and a lot more of complex task solving. So they are really far better by adapting to the changing condition. So comparing those two, single systems are simpler, easier to get up and running, but multi-agent systems really can shine when tasks get more complex. Key idea is to divide some complex task to simpler one and work together to cover and to solve this complex problem. Even those agents can cover for each other when, for example, one agent fails. So this multi-agent system is more resilient. What else? In industrial settings, those multi-agent systems are really showing some potential, because in manufacturing, you can think, for example, of relocating resources or on adjust production lines on the fly. So in logistics, they can help to optimize delivery routes, manage warehouses, and predict demand. There are also, I don't know, maybe applications in finance where they would be used to analyze markets, assess risks, or make the real-time investment decision. So while single agent systems are great for straightforward tasks, the multi-agent systems are opening a lot of new possibilities for tracking more complex challenges. In industry, where we are still talking about flexibility and adaptability, the abilities of the multi-agent systems are really useful. So it's definitely a space worth keeping eye on.
Okay, it means so multi-agent systems are, I think, particularly well suited for industrial settings where we have complex operation, and this single agent is not able to handle all this complexity, I believe. So this is also very interesting area of development when it comes to AI in industry. And since we are at the beginning of the 2025, it is also a good time to look back and think ahead. So I'd like to ask you these questions. What are your thoughts about the prospects for AI and Gen AI in the Polish and European industry in 2025? So, what are your predictions for this year that has already begun?
I think the year 2025 is going to be a year of some evolution rather than a groundbreaking revolutions. Yeah, it's really hard to point a single trend that made completely change how we view industrial processes in the connection with AI. But based on what I've seen and on the data that it is out there, the growth of AI in industry will mainly come from the widespread implementation across different sectors. So whether it is food production, pharmaceutical, forestry, I don't know, automotive sector, oil and gas, the AI's role is to growing steady. So, of course, there are
Okay.
some a couple of key areas where we can see that the growth maybe will be bigger than in other. So, and the adoption is accelerating. The first is already mentioned predictive maintenance. So the mix of maintenance strategies will be changing. There will be a resign from those strategies when we only reacting when the failure occurs to some predictive maintenance, because it was really hard till now to use those predictive strategies for those complex environments when it was not possible to use, for example, one threshold value. Yeah.
Okay,
And then,
so we are moving from reactive to the predictive
yeah,
maintenance, especially for the complex environments when you have
I
complex machines and
I think it would be the case. So so those traditional systems relying on the control of thresholds or some basic diagnostic rules are likely to be replaced by some more sophisticated methods. Maybe those methods that are applying some machine learning concepts or AI, because companies are already collecting massive amounts of data, but it is
okay.
in most cases it is unused now. So applying those AI models to predictive maintenance approaches will be really beneficent for them. And
This is
the
very
second,
interesting what you're saying. Just let me,
Mhm.
could I interrupt you? Because what you said is very interesting, but you said that companies are already collecting massive amounts of data. It means that this data are not used. So it means that they are not analyzed, and this data is not analyzed. But they are there. So it's a great case for a company like ours, like Fabrity, just to gather this data and do the data engineering operations on it. So it's a huge untapped potential, I think, for software development in these areas.
Yes, yes, I think the making use and some having additional value from this data will be the hot trend in the year that already started. So I think the second big area is the emerge of intelligent assistant. I already was pointing on some examples of the human machine interaction and so on, but we will see that the major corporations will integrate these tools even more to their solutions, but also those smaller custom solutions will also emerge for specific use cases. So voice assistant helping maintenance teams to guide you through procedures, suggesting the right settings for adjustments, or even finding some, I don't know, maybe spare parts, also alternatives will emerge, maybe, for example, with the use of, I don't know, augmented reality, yeah, when you will be guided through all those maintenance tasks. And for most part through this year, I think it will be about building on tools we already know. So there will be no this such break, but I think the real game changer will come when the entire industrial processes can be handed over AI. So not just use the AI to assist with things like, I don't know, writing some code for controllers, but letting the AI take full control of the process. But that kind of leap through, I don't think will be happen widely this year, because there is still a way to go both in technical and mental side before we will be ready to trust AI with that level of responsibility.
Thank you. So, what about the future of AI development in Poland? Are there any recent initiatives or policies that stand out and could shape our country's direction in this field?
That's really great question. On December 16th, the Ministry of Digital Affairs published a document that is entitled AI Development Policy in Poland 2025-2030, and it was prepared by a AI working group, in a short GRAI. It's an interesting because it outlines a clear vision of how AI could develop across different areas of life in Poland. So it's not only focused on the industry, but it has a broad context. And this document doesn't just paint a picture to the future; it also highlights where we are now. So it references studies that show that current state of AI adoption in Poland is pretty encouraging, because, for example, nearly 8 out of 10 Polish companies are ready to implement AI-based tools, with only 12% saying that they are not prepared. So it is really a good starting point to implement those solutions. So one of the key takeaways from these reports is the focus on some specialized small language models and multi-agent systems. So in the opinion of authors of this report, these are critical areas, especially from the industry perspective, where solutions and advanced systems can make a big difference. And this type of solutions can be developed in our country. Because what's really exciting, the potential economic impact of the implementations of various AI tools. If the AI policies are implemented effectively, we could see the Poland's GDP grow by as much as 8%, what translates to around 55 billion over the next decade. And that's
Billion
huge.
euro or dollars?
Billion euros, yeah, 55 billion of euros. Yeah, so that's huge.
Yeah, I'd say. And this is interesting what you say in the context of the HAI, because small language models, specialized small language models, are the models that can be used on edge devices to analyze data locally. That's interesting.
Yes, of course. So I think those small models will be a good solution for smaller companies that don't have such amount of investment funds to use some I don't know, expensive tools, and those small models that demand lower hardware capabilities will be a good solution for them. So I think in general the perspectives for AI in Poland are rather optimistic, because the groundwork
I'm happy to hear that.
The groundwork is being laid, and with so much readiness in the business sector, it feels like we are heading in the right direction. I will be exciting to see how this evolves in the next year. But yeah, there are also some negative signs that can rather fast change the optimistic trend.
It is good to mention that we have a good starting point as a country to implement AI countrywide. But what bothers me is when I think about AI development in Poland, is that Poland and also EU, we seem to lag behind the rest of the world. And by the rest of the world, I mean here US and China, which are clearly leading the way in Gen AI or AI research and development. What do you think about that?
Yeah, that's a real valid concern, and it's true that US and China are ahead in terms of mainly founding and large-scale AI initiatives. Because looking at this GRAI report and the state of AI founding in the US, I think Poland and Europe as a whole has a real opportunity to catch up by only focusing creativity and pushing for even greater innovation. So let me give you an example. Training of GPT-4 reportedly cost OpenAI around $78 million. And the next model, GPT-5, is expected to cost, we don't have we have only some estimations, so it can be cost over $500 million to train. Of course, running a single task on such a model currently costs about $5,000. So it is a huge amount of money. Meanwhile, in China, there was a model developed that the name is DeepSeek, and is version 3. And this model outperforms GPT-4 and also Claude Sonnet 3.5 and Llama 3.1 in many benchmarks. And what's the most important, it costs only $5.5 million to train it. So you can see that the gap between GPT models and this smaller model is really, really huge, while those capabilities of both models are more or less similar. And why it is? Because this smaller model use a completely different architecture that requires far fewer GPUs for training. To put it into perspective, Meta AI use 24,000 NVIDIA H100 chips to train its Llama 3 model, whereas those Chinese companies that stands behind the DeepSeek model train it with use only 2,048 NVIDIA H800 chips, and this 800 chips is a stripped down version of the H100 that can be only export to China to some trade restrictions. So even through those costs are still significant, this example shows that the creativity and the openness to unconventional approaches can lead to great results. That's where I see the opportunity for Poland and for Europe as a whole. So by focusing to a smaller AI models that are customized to specific needs, we can found our niche to develop further. So training those models and giving our products that are specialized, we can remain competitive without needing to have some massive budgets like US or China.
So the basic message is a positive one, while these big, huge AI models are beyond our reach, like GPT 3 or 4. We can still focus on creativity and train smaller models that will perform equally well in specialized tasks.
Yeah, we must find our room for innovation to remain competitive in the world race of AI. So build our strong position is not to have large budgets, but be creative and open to some novelties.
Okay, great. But what about EU regulations on AI? I can't help but worry that the EU tendency to overregulate might hold back AI development here in Europe. So there are, and that could have a massive impact of all sectors, including also industry.
Yes.
So what do you think about this?
Yeah, that's a really valid concern, and it's definitely something that is worth discussing, because the EU has introduced two major regulations recently that are shaping the AI landscape. It is the AI Act and the Cyber Resilience Act, and those acts were adopted last year. So AI Act was adopted in March, and the first, it is a, for one side, it is really a great act because it's the first comprehensive legal framework for AI in Europe. Yeah, it's designed to make sure that AI systems are safe, transparent, and responsible. Yes, so it categorizes the systems by risk level from the minimum to unacceptable, and it's focusing on some high risk applications like, maybe biometrics and critical infrastructure management. So in industry, this means that companies that are using AI in critical areas, and the main area that comes first to my mind is any operations that is connected with safe of machinery. Yeah, so it is the one of the most crucial tasks. Then you have to follow some strict rules about transparency and documentations when you involve some AI solutions to the kind of the systems. So due to AI Act, you have to explain how the AI works and keep, for example, some incident logs for further investigations. Why? This builds trust and reduces risk. It also creates some extra work for business trying to implement AI. So it's really I think it will be really, really hard to achieve fast those demands that are written in the AI Act. The next regulation, you want to ask something?
No, I wanted to say that you mentioned that there is also act on cybersecurity.
Yes. Now I'm coming to the second act, this CRA that was also introduced in March last year is focused on the cybersecurity, and it requires manufacturers to build some security measures into their hardware and software from the start and maintain them through the product lifecycle. So it's crucial for AI technologies, which are often targets of cyber attacks and are prone to those attacks. To we have to change our thinking of AI. Yeah, we have to think how these products are designed, how are developed, especially in industry that rely heavily on AI. Not only think about the output of the AI model, but the whole process of the training, the maintaining of the model is now very important to assure high standards, not only functional, but also when talking about cybersecurity. So it's getting tricky because some companies see those regulations that there are some difficult tasks to do, and are already deciding not to release certain products in the European Union because of this regulation. So, for example, Apple's AI tool, Apple Intelligence, which is a part of iOS 18, won't be available in Europe. So Meta is also doing the same thing with its Llama 3.2 model, that is a multimodal AI for creating videos, audio, and other media. OpenAI has also held back its new video generation to Sora from the European market. So yeah, it is really sad. So while this regulations from the other one side aims to protect our users and ensure some transparency, there is a real risk that they could slow down AI development and adoption in Europe. It's something we will need to keep eye on, because whether those rules will help business and researchers, or whether they push Europe further behind the global AI race. Yeah, it's really about finding the right balance between safety and good development.
So I believe you made a good point saying that it's about finding the right balance between the AI regulation, which is necessary from the point of view of the end users, and between AI research, which is very important for companies. So to sum up your predictions for 2025, there will be 4 major trends. First, there will be a steady growth in AI implementation across various sectors, including food production, pharmaceuticals, forestry, and automotive. Second, AI has significant potential to boost Poland's GDP by as much as 8%, which translates to around 55 billion euros over the next decade. Third, to avoid falling behind the US and China in the AI race, we need to focus on creativity and prioritize smaller, more tailored AI models that are customized to specific needs, especially in the industrial context. And last but not least, while the EU regulatory zeal is necessary, it is crucial that it doesn't hinder the generative AI development in Europe, right?
Yeah, everything is correct, but because although the level of optimism is high at industry in Poland, I think it can be a difficult year, a year full of challenges, and a year to ensure that Europe, and even so more Poland, does not fall out of the race in which we are already rather in a distant position. So we are a good starting point, and we cannot to omit possibilities to be in the race. However, I believe we will find a niche where we can work, and also that we will not be cut off from any solutions already offered, which would be a real disaster for us. So the optimism is high, and we have to keep it at high level through the whole year.
Okay, so in coming 2025, we need to do our best to maximize our Polish potential when it comes to generative AI and AI development.
Yeah.
That's all we have for you today. Thank you very much, Wojciech, for sharing all these insights into current AI developments and your predictions for 2025. I'm glad that you could join us and be here on our podcast to talk about Industry 4.0 and about all these AI developments.
Thank you very much for the invitation. It's been a real pleasure to share and discuss all these ideas with you and all listeners.
Thanks for listening, and until the next time, bye.
And bye.
Fabrity specializes in bespoke software development, generative AI, industrial IoT, and data engineering. We build complex solutions for enterprise clients to automate processes, boost efficiency, reduce downtime, and enhance decision-making through effective data analysis. If you have a software project in mind or any questions, feel free to reach out at sales@fabrity.com. And if you have a topic you'd like us to cover or want to join the conversation on Fabrity Talks, we'd love to hear from you. Thanks for listening, and until next time.